The headstock, the string anchor, the carved piece of solid wood at the absolute top of the guitar neck. It isn't just for displaying the brand logo. It must withstand hundreds of pounds of continuous, violent pulling force from the tight steel strings without ever snapping or warping. Tuning machine, the tension controller. A heavy, geared mechanical unit bolted through the back of the headstock, also known as a machine head. It uses an intricate worm gear system to pull the steel string millimeter by millimeter, physically tightening the metal until it reaches the exact mathematical frequency of a perfect musical note. Tuning peg, the mechanical grip. The protruding wing or knob that the guitarist actually turns. Made of die-cast metal, polished bone, or pearloid, it is the physical interface between the musician and the machine, providing the necessary leverage to smoothly rotate the hidden steel gears inside without slipping. String post, the winding axis. A solid metal cylinder protruding through the front of the headstock, featuring a small hole. The raw end of the guitar string is threaded through this hole and aggressively wound around the post, creating a devastatingly tight friction lock that prevents the string from unraveling under immense pressure. Gear housing, the sealed transmission, the metal casing on the back of the tuning machine. In modern, high-end guitars, this isn't open to the air. It is a permanently sealed vault packed with industrial lubrication to ensure the microscopic brass worm gears inside never collect dust, rust, or grind against each other. Ferrule, the stabilizing collar. A small metal ring or washer pressed directly into the wood on the front of the headstock. Wood compresses under pressure. This metal collar physically reinforces the hole, guiding the string post and preventing the immense rotational torque of the string from slowly crushing and destroying the delicate wood. The nut, the 0 point. A thin bar made of bleached bone, brass, or high-density graphite. This is where the guitar actually begins. It physically elevates the strings above the fretboard and perfectly spaces them apart, marking the exact starting point of the string's vibrating length. Nut slot, the friction channel, a microscopic groove filed directly onto the top of the nut. It must be cut with a specialized diamond file. If this slot is too tight, the string will physically bind and choke the tuning. If it is too loose, the string will rattle violently against the wood. Truss rod cover, the access shield. A small piece of plastic, wood, or metal screwed into the headstock just above the nut. It protects the most vital adjustment point of the instrument. Removing this tiny plate gives the luthier direct access to the hidden steel spine that runs the entire length of the guitar's neck. Truss rod nut, the neck calibrator, a heavy steel hex nut hidden deep inside the access cavity. Wood naturally bows under the extreme tension of steel strings. By tightening or loosening this nut with a wrench, the luthier physically bends the steel rod inside the neck, forcing the bowed wood back into absolute dead-straight perfection. String tree, the break angle fixer. A small metal bracket screwed into the face of a flat headstock. On guitars where the headstock doesn't lean back, this forces the highest, thinnest strings downward. This creates a sharp break angle over the nut, physically preventing the strings from popping out of their slots when the player bends a note. Fretboard, the musical canvas. A thick slab of extremely hard, dense wood like rosewood, ebony, or maple, glued directly to the neck. It isn't just flat wood, it is sanded with a microscopic intentional curve or radius that perfectly matches the natural resting curve of the human hand, allowing for effortless, lightning-fast chord changes. Fret wire, the pitch divider. Thin, precisely crowned strips of nickel silver or stainless steel. Guitars aren't like violins. When you press a string down, the string physically bends over this wire, immediately shortening its vibrating length and locking the sound into one mathematically perfect musical interval. Fret tang, the hidden anchor. The invisible, jagged bottom half of the fret wire that is driven deep into the wood. Frets aren't glued in. This piece of metal is covered in microscopic, vicious barbs. When hammered into a perfectly cut slot, the barbs bite aggressively into the wood grain, locking the fret in permanently. Position inlay, the visual navigator. Discs or intricate shapes cut from mother-of-pearl, abalone, or clay, embedded perfectly flush into the fretboard. They aren't just decorative. Placed on specific mathematical intervals like the 5th, 7th, and 12th frets, they act as an instant high-contrast visual roadmap, allowing the guitarist to leap across the neck without ever getting lost. Neck profile, the player's grip. The specific carved shape of the back of the neck, whether it is a chunky 50s U shape or a modern slim C, this carved curvature dictates exactly how the guitarist's thumb rests, directly impacting comfort, speed, and endurance during complex performances. Fretboard radius, the invisible curve, the intentional arch sanded into the surface of the fretboard. Fretboards aren't flat. A rounder vintage radius makes chords easy, while a flatter modern radius prevents notes from choking out when a guitarist violently bends a string, providing the perfect ergonomic balance for different playing styles. Neck binding, the structured edge. A thin strip of plastic or celluloid wrapped around the edge of the fretboard. More than just a decorative outline, it covers the jagged ends of the fret wires, creating a smooth, sealed edge that protects the hand from scratches and locks moisture out of the vital neckwood. Side dots, the player's map. Microscopic discs embedded directly into the side binding of the neck. While the audience sees the main fretboard inlays, these are the only markers the guitarist can actually see while playing. They provide an instant high-contrast visual roadmap to their exact position on the neck, even in the darkest stages. Neck joint, the structural anchor, the critical area where the neckwood violently meets the bodywood. In a boton joint, 4 massive steel screws crush the neck into a precise pocket, creating an interchangeable rigid connection that optimizes the transfer of vibrational energy from the strings directly into the body. Pickguard, the armor plate. A large sheet of plastic or celluloid screwed onto the front of the body. Named the scratch plate for a reason. It acts as an interchangeable shield, physically protecting the delicate, expensive wood finish from being destroyed by the musician's aggressive pick attacks and enthusiastic strumming. Single coil pickup. The absolute core of the electric guitar sound. It uses 6 magnetic poles wrapped tens of thousands of times in microscopic copper wire. This configuration creates a single, sensitive electromagnetic field that captures string vibration with immense clarity, producing the iconic, bright, cutting, and transparent tone of classic rock and blues. Humbucker pickup. The powerful giant. A pickup featuring 2 massive side-by-side single coils wired together. It does exactly what it says. By combining the coils, it violently bucks or cancels out the 60-cycle hum inherent in single coils, simultaneously doubling the output to create a massive, warm, thick, and devastatingly powerful sound. Pole piece, the magnetic focal point. The individual metal rod directly beneath each guitar string. In a humbucker, this specific screw allows the guitarist to mathematically fine-tune the magnetic field. By raising or lowering this single screw, you precisely adjust the volume of just one string, achieving a perfectly balanced output across the entire fretboard. Pickup bobbin, the hidden core. The internal spool, typically made of plastic or vulcanized fiber, that forms the foundation of the pickup. This is what the wire wraps around. It is the indispensable framework that holds the magnetic pole pieces in absolute alignment while acting as the vital cylinder around which tens of thousands of microscopic copper windings create the electromagnetic magic. Volume knob, the output controller. A rotational potentiometer mounted on the guitar's face. It doesn't just make it loud. By rotating this knob, you physically adjust the electrical resistance, seamlessly throttling the signal going to the amplifier. This allows the player to clean up a high-gain sound or create ethereal, violin-like volume swells with microscopic control. Tone knob, the darkness filter. Visually identical to the volume knob, but serving a completely different electrical purpose. It functions as a variable high-pass filter. Turning this knob down physically drains the brightest, sharpest high frequencies directly to ground, instantly transforming a piercing lead tone into a warm, dark, smooth, jazzy voice. Potentiometer, the variable resistor. The complex electronic component hidden beneath the plastic knob. This is the actual machine. It is a variable resistor that uses a delicate internal wiper gliding across a carbon track. This unseen mechanical interaction is what physically chokes or unleashes the flow of electrons, directly controlling the guitar's volume and tone. Selector switch, the tone navigator. A multi-position mechanical switch, usually a 3-way or 5-way. It defines the guitar's signal pathway. With one quick snap of this switch, the guitarist instantly completely rewrites the internal circuitry, choosing between the cutting bright voice of the bridge pickup, the smooth warmth of the neck pickup, or combining them for a unique, complex, out-of-phase sound. Output jack, the final terminal. A heavy metal receptacle, usually 1/4 inch, bolted to the guitar's edge. This is the absolute end of the line. It is the vital physical terminal where the guitar's entire electrical journey culminates, receiving the combined signal from the pickup's volume and tone circuits and launching it down the cable directly to the amplifier. The fixed bridge, the immovable anchor, a solid block of machined brass or steel bolted directly flush to the guitar body. Because it has no moving parts, it transfers the maximum amount of string vibration directly into the wood, providing massive sustain and absolute tuning stability. Bridge saddle, the final resting point, the small individual metal block that each string physically sits on. This is the exact counterpart to the nut. The distance between the nut and this tiny piece of metal dictates the entire mathematical scale length of the guitar, defining how every single note on the fretboard sounds. Intonation screw, the pitch corrector. A long horizontal bolt attached to the back of every bridge saddle. Strings are imperfect. By turning this screw, the luthier moves the saddle forward or backward by microscopic fractions of a millimeter, ensuring the guitar plays perfectly in tune all the way up the highest frets. Tremolo bridge, the floating fulcrum. A complex bridge assembly that is not bolted flat, but pivots on a knife-edge hinge. It exists in a violent state of perfect equilibrium, balancing the massive pulling tension of the steel strings against the pulling tension of hidden steel springs hidden in the back of the guitar. Tremolo arm, the pitch lever. A bent steel rod that screws directly into the tremolo bridge block, often called a whammy bar. When the guitarist presses down on this lever, they physically tilt the entire bridge forward, instantly dropping the tension of all 6 strings simultaneously to create dramatic, expressive pitch dives. Tremolo block, the hidden mass. A heavy solid block of brass or steel hanging underneath the bridge, invisible inside the guitar body. Mass equals sustain. This heavy chunk of metal acts as an acoustic anchor, capturing the vibrating energy of the strings and preventing it from instantly dying out, allowing notes to ring for minutes. Tremolo springs, the countertension. Heavy-duty coiled steel springs hidden in the back cavity of the guitar. This is the other half of the balancing act. These springs pull the tremolo block backward, constantly fighting against the pulling force of the guitar strings, keeping the bridge perfectly level and returning it to 0 after a pitch dive. Spring claw, the tension anchor. A jagged piece of metal drilled deep into the wood inside the back cavity. It features multiple hooks holding the tremolo springs. By driving the 2 massive mounting screws deeper into the wood, the luthier increases the spring tension, perfectly calibrating the floating bridge to accommodate thicker, heavier guitar strings. Tune-o-matic bridge, the elevated arch. a classic narrow metal bridge suspended above the guitar body on two threaded posts. Originally designed for archtop guitars, it allows the guitarist to effortlessly raise or lower the overall action of all the strings simultaneously, simply by turning the two thumb wheels at either end of the bridge stop bar tailpiece, the dead end. A solid, heavy bar of metal bolted directly behind the two-pneumatic bridge. The bridge guides the strings, but this stops them. The string ends are threaded directly through this heavy bar, firmly anchoring them to the body and creating the necessary downward brake angle over the bridge saddle's tailpiece stud. The structural bolt. Massive, heavy-duty steel bolts driven deep into the guitar body. The stop bar holds the string tension, but these hold the stop bar. They are the critical structural pillars that prevent the tailpiece from being violently ripped out of the wood by the continuous pull of the steel strings. Bridge plate. The magnetic surround. A wide, flat piece of metal that houses both the bridge saddles and the bridge pickup, found famously on Telecaster-style guitars. By surrounding the magnetic pickup with a massive sheet of steel or brass, it physically alters the magnetic field, contributing to the famous piercing twang and aggressive bite that these guitars are known for. String ferrules. The through-body anchors. Small metal cups pressed into the back of the guitar body. In a through-body design, there is no tailpiece. The strings are threaded entirely through the thick wood of the guitar body from back to front. These metal cups catch the ball ends of the strings, ensuring they don't crush into the soft wood under tension. Strap button. The carrying peg. A small flared metal peg screwed into the edges of the guitar body. It seems incredibly simple, but it is critical. This single screw must reliably hold the entire 10-pound weight of the expensive instrument against the musician's body while they move aggressively across a stage. Strap lock. The stage insurance. A heavy two-part mechanical locking system. Standard leather straps stretch and slip off buttons easily. The professional upgrades to this mechanism. The strap physically clicks and locks onto the guitar with a spring-loaded ball bearing, making it mathematically impossible for the guitar to fall, no matter how violently the musician jumps.